Welcome everyone to this week's Legend Tech Talk. I'm excited to bring to you one of our elite biological products that we offer at Legend Seeds through Yieldmaster Solutions, NueNutri. And with me today, I have Josh O'Brien with Agri Sciences Biologicals, and he's going to talk a little bit today about how NueNutri can protect your yield potential in stressful conditions. Josh, I'll turn it over to you.
Thank you very much, Amber. I appreciate it. And good morning, everybody. It's somewhat fitting that today's Tech Talk is about a product that helps mitigate abiotic stress, and particularly stress caused by weather with the conditions that we're having today. So hopefully all of you that are in the pathway of the storms are staying safe today, and I wish nothing but the best for you all as we get through the day. And I told Amber, I asked her on Friday, I said, how can we make this talk about the impact of weather on our crops a little more dramatic? I did not know she was going to dial up severe storms, so I apologize for those of you. Amber took it a little too far, but we'll go ahead and get started here. So again, a lot of you have probably heard my voice on other conversations with other products before, and it's great to be back with you to talk about this product today. What we're going to talk about is a product called NueNutri. And it's a little bit different than some of the other things I've spoken to you about in the past. For example, we call this product a powerful bionutrient that contains peptides and amino acids. And you're going to learn a lot more about that as we progress through the PowerPoint here over the next half hour or so on just what those ingredients mean and what they can do for a crop. So I hope that you ask a lot of questions, and I'm happy to stop as we go through that with Amber and have her read off those questions as we get going. But without further ado, let's dive into it and let's get started. Okay, so not to spend a lot of time on this, but just a real quick who we are, right? Because you've probably never heard the name Agri Sciences Biologicals. We are a company that is based out of Europe. We have a parent company called Agri Sciences that has a large manufacturing facility in Turkey. That picture on the top of the screen that you see there is our manufacturing and blending facility. We have over 200 employees. We have subsidiaries around the world in Chile, Egypt, Jordan, Latin America, and then obviously now in the United States. We have over 250 different registered crop protection products, and we export internationally to 25 countries around the world. Fast forward to 2023, and we put a real focus on developing out our sustainability platform and products that go along with that. NueNutri certainly falls into that category. So that was established in 2023. Our priority markets are the United States and Europe with those more sustainable products. And then we also do a lot of custom formulation as well. So that's just a very quick snapshot of who we are, what we do, and where we're located. Our focus primarily is biostimulants, specialty fertilizers, and then we're moving into biopesticides. So today we're going to be talking more about a biostimulant product than anything else. However, over the future, you will see some of our value-added fertilizer products that have biological components to them. And hopefully, if our R&D pipeline is correctly filled, you'll also see some biopesticide products as we move over the next several years as well. So let's get into the topic of today's conversation, though. Stress, weather, abiotic stress. What is it? How does it impact our crop, and what's the result of it? So just a few kind of real interesting little tidbits. I have a feeling that I don't need to explain to the people on this call the impact of Mother Nature on their crops. Unfortunately, many of you have probably seen the impact of heat and drought, or even excess moisture in the spring on your crops over the last 3 to 4 years. So you understand this very well. But just a few statistics to kind of get you warmed up for the conversation here today. Let's start with corn. Heat stress during pollination can reduce yields by up to 50%. Now, 50% is a pretty dramatic number. I don't think unless you have extreme heat and drought during pollination, you're going to see that. But I would venture to guess that a lot of you over the past 3 years have gotten to that point of pollination. Your crop has looked pretty good. You've got that heat stress, and then you've really seen the result of that during harvest, where that ear just didn't fill correctly. It certainly did not pollinate correctly, and you've seen that reduction in yield. So it doesn't take 30 days or 60 days or even a full season of heat stress to have that impact. We know that just a 10-day drought during grain fill can cut your yields by 25 to 30%. So think about that. I mean, how often throughout the summer do we have that 10 to 14 day high heat, low moisture period? It seems to be more often than not anymore. So switching gears into the soybean side, what does that look like when we talk heat and drought stress and just abiotic stress in general? Well, during drought, drought during flowering and pod filling can reduce yields by 30 to 40%. A lot of you in the past couple of years have probably seen things like seed size become dramatically smaller during those hot and dry periods of pod fill. I know that was a common complaint that we've had over the last couple of years. And then for those of us that have been in those really hot areas, that heat above 95 degrees during pod development can actually reduce yields by 20%. So soybeans can lose 20% yield within just 1 week of drought. Again, we're not talking sustained season-long drought. We're talking 7 to 10 to 14 days of hot, dry weather and the impact that has at those critical stages of that plant cycle. And the last but not least, just the last example is wheat. If you have combined heat and drought during grain fill, you can see up to 40% of yield loss, and then heat above 86 degrees during flowering can reduce yields by 25 to 50%. So kind of a lot of the same message there, guys, which is that it doesn't take a lot of days for heat and drought to have an impact. And we really need to figure out how we can mitigate some of those impacts, particularly during the critical development stages of the plant. So that's where we come in. Our product is called NueNutri. It's kind of spelled a little weird. But NueNutri is a liquid biostimulant with vinases, and we'll talk about that here in a little bit, amino acids, and micronutrients that boost flowering and improves crop yield by reducing flower abortion and mitigating that abiotic stress, especially during the pre-flowering stages. So we're going to break this product down here in a couple slides on just what exactly is in there and how it performs. But some of the key benefits that you could expect from using this product is that we stimulate the plant metabolism to limit flower abortion and maximize yield. We improve the uniformity of the crop. We will enhance that nutrient use efficiency. And then we're going to reduce the effect of that plant abiotic stress, including drought, frost, and high temperatures. So over the next 20-25 minutes, we'll talk about just how we do that. Let's start from the beginning, though, which is just what is this product? How is it made, right? Because this is different than really anything else that we've sold through YMS in the past, being that we do not have a live microbial or bacteria in this product. So let's talk about how we make it and what it is. So step one is we want to source our materials. So we start with proteins from vinasse. And vinasse is a liquid byproduct that's generated during the fermentation process used to make baker's yeast. So when they're making this baker's yeast, essentially they'll start with a small cell culture, right? It might be in just in a little tiny vial. They'll add some liquid to that. They'll grow it up a little bit. That'll then get moved to maybe something the size of a jar. That'll then get grown up and moved to maybe a 5-gallon bucket type size container. Eventually, it ends up in a 3,000-gallon fermentation tank. Think about like when you make, if you've ever been to a microbrewery and you've seen those tanks sitting there. What we do is at the point when that yeast is going to be separated and completely isolated to be sent off to a bakery or a baking company, we take all the liquid that's in that process and create it into a product. Because over that period of weeks and months, we know that all those cells have created a lot of beneficial enzymes and amino acids, and we've also created a situation to where there's a lot of protein in there. So we tap into that right at that period when that material is getting separated. So what happens then is we have a whole lot of protein that we're left with inside of this liquid. And protein's great, but we need to break it down into its components, into its parts to really have a benefit. So that's called a hydrolysis process. So we use this hydrolysis process to break down those proteins, and what that leaves us with are two very fundamental ingredients, which are amino acids and peptides. And if you string enough amino acids together, you get a chain of a peptide. Okay. The last thing we want to do then is we want to concentrate that into a usable form that's beneficial for crop use. This is where the secret sauce and the proprietariness comes into the recipe here, okay? Because you want to make sure you break down those proteins enough that we have enough amino acids to work instantly, but yet we have enough peptides that are going to benefit us long term. So there's kind of a real balance of how much we want to hydrolyze it down and break it down into its components. So once we're done with that, we then mix those amino acids and those proteins with other powerful ingredients to create our biostimulant product, things like micronutrients, for example, that complement what we're trying to do. So you can see that we're a little bit different than a biological product. This is why we're technically considered a biostimulant. Our product will stimulate natural microflora, but it'll also unlock different hormonal pathways in the plant. So that is, in a nutshell, a very complicated process broken down to be very simple for you. Start with protein, hydrolyze it to peptides and amino acids, concentrate it, bottle it, and sell it. So I threw a lot of just ingredients at you just then, but let's break it down a little bit and talk about what it means in very simple terms. So we talked about, breaking the protein into peptides and into amino acids. And there's actually the easiest analogy I have on this is if you think about a lot of medicine lately, like a lot of pharmaceuticals are now starting to utilize peptides, for example. Insulin, a very common medicine that's out there. Insulin is just two peptide chains that are tied together. So this is really not something that is completely unheard of. It's just that we are taking it to the level of bringing it to plant health versus human health, I guess, for lack of a better term. So when we talk about peptides, let's talk about what they are and what they do. They are really the key that unlocks the plant hormonal pathway. So if you see on the bottom of the slide there, I have a little key that unlocks that lock, right? Peptides will elicit growth. They will boost cell growth. They'll create that cell division. They also help regulate hormones. So they control the growth hormones for better development. And last but not least, they support the roots and shoots development, mainly through unlocking that plant hormonal pathway. So if you think about it in very simple terms, peptides are growth elicitors. They unlock the plant hormonal pathway. This is a big reason why we see additional flower setting, for example, on soybeans, because we're unlocking that plant hormonal pathway that allows that plant to put more flowers on it. This is why we see better tillering on wheat. This is why we see better ear set and ear fill on corn. We're unlocking that plant hormonal pathway to get that best fill that we can get. Okay. So if we're going to elicit all of this additional growth and all of this additional potential, we want to make sure we have a fuel tank that can take care of that additional growth and not just, lose it to potential. That's where the amino acids come in. And if you look on the bottom of the slide there, I have a little fuel tank for amino acids. That's because they sustain that additional growth. So through nutrient use efficiency, right, we're improving the nutrient uptake and the utilization to support the plant. We're also providing instantly plant available food. Amino acids serve as a natural food source for plants that promote healthy roots and overall vitality. And then last but not least, we're also increasing the metabolism of that plant. So we're boosting the metabolism and the energy production that help the plants cope with stress and environmental challenges. So what that means is that if we're going to put NPK or micronutrients into the plant, the amino acids help those get utilized more efficiently, and they help that metabolism sustain it more efficiently. So when these peptides put all these additional flowers or all this additional potential growth into the plant, the amino acids are there to make sure that that potential gets utilized and converted into yield. Last but not least, when we combine these ingredients together, and we utilize the bioactive material in the product. We talked about that in the last slide, a little bit of the secret sauce that's added in at the end. What we have are osmoprotectants. And that's just a very fancy way of saying we have ingredients that allow the plant to regulate water more efficiently. So we can enhance water retention. They will improve the plant's ability to retain water during dry conditions. And then it will also help with cell protection. So osmoprotectants will protect the cell from being damaged by oxidative stress. This essentially means that, when a cell loses too much water, it collapses on itself and it dies off. And if you get too many of those cells that are dying off too quickly, that's when you start seeing tissue damage on the actual plant itself. So this is a really fancy way of saying that we prime the plant to be ready for heat and drought stress ahead of time. So I know you guys are familiar with some other products in the YMS portfolio that also work by priming the plant. We're doing a similar thing, but we're priming it for heat and drought. The easiest analogy is think about running a marathon, right? If you went out there on day one and you had no training and you said, I'm just going to run a marathon tomorrow, why not? Chances are, look, maybe you'll get through it. You probably, potentially could finish the race, but you're going to be in tough shape when you're done. You're going to be sore. Your recovery time is going to be dramatically longer, and you're probably going to struggle throughout that race. Versus if you prime yourself and train for it and are well hydrated going into that race, you're going to recover much faster. You're going to be in much better shape throughout the race, and you're probably going to perform a lot better. We are priming this plant to know that it has heat and drought coming to it, and we're telling it to regulate its water much more efficiently than it would without us inside of the crop. Okay, so again, one of the common things, I'm not going to go through this slide word by word, but one of the common comments I always get on this product is, hey, that sounds really cool. I like the idea of this. I like the ability of getting through heat and drought stress. If I get a week or two of heat and drought, I'll put your product down after the fact and try to recover, much better. While that can certainly help, this is not a recovery product necessarily. What I mean by that is everything I just talked about in the last slide is we want to make sure we prevent the damage. Because if you prevent damage, you are always going to be better off than trying to fix the damage after the fact, right? If we can build that early resilience, if we can reduce the recovery time, if we can make the resources more efficient, we can minimize that long-term damage. If we're not in the crop ahead of time, we have less impact on mitigating that yield loss. We have slower recovery times. We have higher damage accumulations. We have increased strain on our resources that are in that plant. Ultimately, we have higher costs associated with the not using the product. So I don't want to discourage you from using this if you've already had some damage to your crop, but this is not necessarily a recovery product that you put down after the fact. We want to be in the plant ahead of the fact to prime it to be ready for that stress ahead of time. Okay, so let's shift gears a little bit. We've talked a lot about peptides and amino acids and what they do in the plant and how they work and all of that good stuff. But let's just break it down to nuts and bolts. How does this product impact the plant? Okay. Heat and drought tolerance, we talked about that. We're going to have a lot better resilience to extreme temperatures, to water scarcity, to improving survival rates under the stress. That is a huge part of what we're doing. However, I do not want you to think that this is only a product that works well if we get heat and drought stress, because there's so much more to it than that. Let's talk flower retention, for example, with soybeans, okay? We talked about the peptides that are eliciting a lot more flower production, okay? We also have the amino acids in there which help with flower retention long term, which help to eliminate some of that flower abortion. For example, many of you probably know this, but a typical soybean plant will put on anywhere from 40 to 80% additional flowers than what it actually utilizes to pods. Why does it do that? Well, the soybean plant has learned over time that it needs to overproduce flowers because at some point it's going to go through a stress situation when it needs to abort those flowers. So it wants to make sure it has plenty of flowers to abort when it goes through that stress. So even on an average year, if you have adequate moisture, we know that we're going to lose flowers, right? It's part of Mother Nature, it's natural. But what if we could retain just a little bit more of those flowers, maybe 5% more, 7% more of those flowers and keep them from aborting? That gives us 5 to 7% more potential for those flowers to convert to pods and ultimately to convert to yield, right? So even if we don't have a quote unquote significantly hot, dry year, we know that there's the ability of this product to just convert flowers from aborting into actual pods. Okay. The second thing is the nutrient use efficiency. I kind of skipped over this pretty quickly, but earlier when I mentioned that we have a weird name, it's called NueNutri, and it's spelled N-U-E, Nutri. The reason it's spelled that way is the N-U-E stands for nutrient use efficiency. One of the very first things we knew about this product was how much it actually impacts the nutrient uptake into the plant, but also then impacts the plant on how it utilizes that nutrients once it's actually inside of the plant. So we are a biostimulant. Think of that word stimulant. What does that mean? It means we're speeding things up. We're stimulating it, right? So we're making it more active. So when we apply our product, we know that some of it gets in the plant and some of it gets into the soil. We're going to have a real impact on the microflora or the bacteria and microbes in the actual rhizosphere of the plant. We're going to stimulate those bacteria. We're going to make them more effective. We're going to make them work harder. We're going to make them work faster. We're going to get more nutrient to that plant. And then once it gets inside the plant, we've opened up those plant hormonal pathways that now that plant has a better opportunity of converting that additional nutrient, that additional efficiency into higher yields. So nutrient use efficiency is a very important part of what we do as well. And the last but not least, the hormonal pathway activation. Yes, that is a big reason why we see the additional flowering, the additional tillering, the additional growth on the corn. But there's so much more that goes into that as well. I mean, I think if you guys get bored one afternoon, go down the rabbit hole of Googling, hormonal pathway activation in corn and soybean plants. You're going to see a wide array of what that can do for a plant. You're going to see how it can help that plant just be overall more resilient, stand up on its own a lot better, have a better immune system. There's so much more that goes along with that than just necessarily creating more flowers or more growth. So those are the four big reasons of why we think the impact on plant production is significantly beneficial to using NueNutri. So we've talked a lot now about what it is, why it works. Let's talk about how to use it. Okay. I will tell you that this is a little bit more of an art than a science because we're dealing with growers from the western part of North Dakota to the southern part of Wisconsin and everywhere in between. And there's a lot of variance between the weather, the soil types, the crops that you guys grow. Okay. But in general, this is what we would recommend for application rates. Soybeans, 32 ounces per acre. And we want to apply it just prior to flowering. Why do we want to apply it just prior to flowering? Well, we are not a systemic beneficial product, meaning we do not stay in the plant for the full season. A lot of the microbial products that you guys are using from YMS, they're systemic. They're in that crop all season long. We have a period of time that our product is beneficial inside the actual plant before it dissolves. That period of time is roughly 3 to 4 weeks. Right? So if you look at how long a soybean plant flowers through the summer, it really depends on what part of the country that you're in, but usually 3 to 4 weeks is a good jag of time that you're actually flowering, right? It's a pretty good amount of time that we're going to be in that plant during flowering. So we want to make sure we get applied as close to flowering as possible, and ideally just ahead of flowering because we have those peptides in there that can initiate that additional flower set. Okay, so apply us at R1. If you're making a couple passes across the field and you want to split apply us, you can certainly do that. 16 ounces, maybe at R1. And if you're coming back later on in the season with a late season fungicide and you want to do your other 16 ounces then, you can certainly do that. The main goal on that situation would not necessarily be to initiate more flowering. It would be to really make sure that we get as good a pod fill as possible and to eliminate some of that heat and drought stress later in the summer. So you're certainly welcome to do that on soybeans. Corn. Corn's a little different. Corn has two very distinct phases in its crop cycle or crop development that are critical, right? We have that ear set, which is just prior to V5. So somewhere in that V2 to V4 would be a great time to apply it to really make sure that we're going into ear set in a good position, to make sure that we're initiating as big of an ear set as we can possibly get, and to make sure that plant is as confident in its abilities as possible right at ear set. The other one that we have is ear fill, right around pollination there. If you're coming out with a late fungicide, a pre-tassel fungicide, I know a lot of guys are getting more and more active with tar spot applications. I would recommend if you know you're coming in twice throughout that season, once early and once late, I would recommend you split apply it, 16 ounces at each level. If you don't know for sure if you're coming back on that late application or not, I would put the full 32 ounces down at ear set. Okay, that would be how I would apply it. But knowing that we want to be in the plant at the critical stages of development, those would be the two areas that I would pick to apply the product. And last but not least would be our wheat timing. Again, if we could get in just ahead of tillering, that typically is going to be our best results. This is where it gets a little bit interesting though, because for example, I had a grower call me out of Kansas, southwest Kansas. Has two very different situations. He's got dryland wheat and he's got irrigated wheat. He has two very different problems. On his dryland wheat, he doesn't necessarily want to produce a lot more tillers because he has a hard time filling the tillers that he's already produced because they get so hot and so dry, and they don't put a lot of nutrition down on that wheat because it's not very high value ground. Okay, so for us in that situation, applying it later on after tillering to make sure that we convert as many of those tillers to a good head size and to a good yield is more important to him. On his other ground that's irrigated, he knows he's got enough moisture that he can get those tillers to fill. So in that situation, he's going down at flag leaf or just prior to tillering, and he's actually putting down the product then in order to produce as many tillers as possible to hopefully convert as many of those to a good head size as possible. So with wheat, it's a little bit more tricky depending on what your situation is and what part of the country that you live in on when you would want to apply it. Okay, so storage and handling, let's talk about that just a little bit. Again, compatibility, we kind of talked about this a little bit in the last slide. Yes, it is compatible with we say most herbicides, fungicides, and fertilizers because we haven't tested every single thing out there, but so far we have not found anything that we're not compatible with. Always do a jar test, and then it can be added at any point in the tank. So I know with the live microbial products, that order of mixture is very important, and rightfully so. But with this, we're a little less concerned about at what point do we actually go into the tank. So, add us in the beginning, add us in the end. It doesn't really make that much difference to us. Storage and handling, mainly just because it's good practice for liquid products to keep them between 40 degrees and 100 degrees. I mean, in general, just follow that guideline. That gives you a wide enough range that you're probably not going to run into too much storage, troubles. And then we advertise a 3-year shelf life, but in all reality, there's nothing in here that expires or goes bad. So realistically, you're probably going to have even longer than that. But we'll put that 3-year shelf life on the label. So let's dive into a little bit of data. Just to circle back to that nutrient question, though, one thing I mentioned earlier is that we do have a little bit of nitrogen, a little bit of potassium in there. It's a 203 package is what it is. So it's not enough to really make a huge difference from a fertility standpoint, but we are foliar applying it on there to give it just a hint of nutrition. And then in terms of the actual micronutrients, we have some trace elements in there like sulfur, we have manganese, and we have a little bit of moly in there as well. So molybdenum is one that's getting a lot of attention lately. Certainly sulfur is getting a lot of attention just because we used to have plenty of sulfur in our atmosphere and we cleaned up the environment quite a bit. So now we don't get as much sulfur through the rain. So a lot of guys are applying sulfur. So we do have some trace elements in there as well, besides just the amino acids and the peptides. Okay, moving on to data. 2024, we did trials and we really tried to cherry pick some areas that we knew were going to have stress because we wanted to see this thing in action, right? So we brought in some universities and some independent trial agencies to look at this for us. This is North Carolina State, If you think about heat stress on soybeans, North Carolina usually is about as hot as it's going to get. And last year, certainly they had some dry weather as well. So we did see, if you look at the control there, it was a little over 74 bushels. We had a 77 bushel average there. So we were just, just under 3 bushels per acre better than what the control was in this particular North Carolina State University trial. At their second location that they did, this one was really interesting to me. I saw the control and it was a little over 100 bushels, and I was nervous about, oh man, if they're already growing 101 bushel soybeans, how much more can we really add to that? But pleasantly surprised to see that, again, through the replicated trials there, that we did actually improve it by 3 bushel there. So this just really shows that whether you're in a low yielding environment or an extremely high yielding environment, chances are we're leaving some bushels on the table due to abiotic stress throughout the course of the season. And then here, this is the one that, definitely don't take this for gospel and don't take this as what the average should be, but this shows you the range and the horsepower that this thing actually has. So this was in Glasgow, Missouri, up in the northeast corner of Missouri there. They had a lot of stress during flowering last year. Okay, they were dry, they were hot. So we used a group called Total Acre, which is an independent research organization. We used them for some trials last year, and through their replicated field trials, we ended up getting an 11 bushel back in this situation on soybeans. Again, not the norm. I wouldn't expect this every year, but it does just go to show you that if you get that stress at that critical timeline, which is flowering for soybeans, we have a huge, huge potential to be able to mitigate some of that pressure and then add more bushels to your final yield. So really, really exciting result there to see just what this thing can actually do. So with that, I want to thank you guys for jumping on today and listening to me talk about this product. And I want to thank YMS for offering the product to Legend and its dealer network.
I just want to thank everyone for joining us this morning on another Legend Tech Talk. And again, thank you, Josh, for joining us this morning. Legend Seeds is proud to offer an elite lineup of biological products. So if you have any further questions, don't hesitate to reach out to any Legend account manager, and we'd be happy to answer your questions.